Does the derivative of this piecewise function exist at x is equal to 0? Well, the derivative at 0 is a limit, and there's two different versions of the definition that you can use. I'm going to write down this one. F prime at 0 is the limit as x goes to 0 of the fraction f of x minus f of 0 all over x minus 0. So if this limit exists based off of this function, then so does the derivative at 0 by definition. Let's more carefully analyze this limit and in fact simplify it by using the definition of f. First of all, f of 0 is equal to 0, so you can replace this with the number 0. F of x, well, since x is approaching 0 in a limit it never equals 0, which means f of x is the same thing as this thing here. Let's replace those two things. So f prime of 0 is the limit as x goes to 0 of, okay, again, f of x itself, since x is not equal to 0, is this. So I'll put x squared times sine of 1 over x. We then subtract off what the function is equal to at 0, which just so happens to be 0. So I'll put 0 here. And we can further simplify this as the limit as x goes to 0 of, I just realized I put a 1 here. That should have been a 0. Don't know how that happened. But anyway, I don't need to write these minus zeros. I can just put this over that. That's x squared times sine of 1 over x all over x. And furthermore, you can reduce this by 1 and completely cancel the x's from the denominator to get this much more simplified limit. The limit as x goes to 0 of simply x times sine of 1 over x. Okay, so to show that the derivative at 0 exists is the same thing as showing that this limit exists here. And how do we do that? We're going to use the squeeze theorem. Essentially, we're going to demonstrate that this limit is equal to 0, which is something that exists, meaning the derivative exists. So what does that process look like? Well, for any x that is greater than 0, I know that sine of 1 over x is less than or equal to 1, and it's greater than or equal to negative 1. Now, if x is positive, I can multiply through this inequality by x. We get negative x is less than or equal to x times sine of 1 over x, and that's less than x. Now, as x goes to 0, this goes to 0, this goes to 0, and therefore, as this is between, its limit goes to 0 as well. I'm not writing down all the details for this, as we've done this in other problems, but this is what the squeeze theorem says. This thing is above it, this thing is below it. As we head to 0, these two things go to 0, well, this must as well. You should also check this for x's that are less than 0. The process is almost identical, except the direction of the inequalities will change. So long story short, this limit is 0. It's equal to the derivative by definition, and therefore the derivative exists at 0.